In this session, we are going to talk about using statistics. So basically to add value to the kind of analysis that we have done, to the kind of dashboards that we have built, to the kind of stories that we have told, we are trying to add some value to them, right? The different data visualizations, whatever we have created, we are trying to go for some kind of deeper analysis on the top of them, right? So sometimes I may want to use some kind of statistics to go more and more deeper. So basically, apart from looking from outliers in the data using a scatter plot, I want to even understand the distribution of the data. Or in some cases, I may want to look at the trend in the data. In some cases, I may be more interested in doing some kind of forecasting based on the data. So, all these come as a part of enhancements. And Tableau is a very good tool in terms of enhancing the visualization with the statistical analysis. So, three major things which Tableau can help us out in statistical analysis is it helps us in identifying the trends, it helps us in coming out with the distributions of the data, and to some extent it can deal with the basic forecasting aspect as well. So to our visual analysis, some kind of value addition comes out quickly, right? And it also has a facility where you can integrate with R. Today, the powerful software for statistical analysis. So even that aspect can be taken care by Tableau, which is a powerful tool, which is becoming a powerful tool for statistical data analysis. So what we'll do is we'll try looking at understanding all these dimensions. So initially we'll see how it can help me in terms of doing a trending, how it can help me to understand the trend that is present in my data, right? So we will take the superstore example itself, or right, we'll take the trend superstore example itself just to understand the process. Okay, so let me connect to that same, or do I have any other data? I don't think we have any other data set. So let me connect to the superstore itself to understand this. Okay, so I am connecting to the superstore data set. So I want to see how I can utilize the trend analysis on this particular data set. Right? Now I'll look at the sales. I am looking at the sales for every quarter. So I am taking the order ID here. Oh, what is that I have taken? Do not add. I'll take order date. Okay. So probably this is not the way. Let me do it the other way. So I'm taking the order date here and I'm taking the sales here. So it is showing 2011, 12, 13, 14. These are the numbers. And probably I can take the things on a quarterly basis. So this is the way my numbers are moving over the last 4 quarters, right? So this one I can very well differentiate, and on this I can very well bring out the trend analysis, right? Now I would like to understand how the trend has been. So what could be the number for the future? So I'll go to this analysis. I say trend line, right? And I'm saying show a trend line. And when I'm looking at the show a trend line, it is showing one line here along with something this side and this side. These are called as confidence intervals. So I'm getting a new trend line, and so I can very well choose the kind of a trend line. By default, I get a linear trend line, right? Now we can change the trend line also. Probably you can get into edit. Now you see, you can go, instead of a linear trend line, you can go with a logarithmic or an exponential or a polynomial, right? And for every, now here, let's say I want to do a small change. So this is the trend for the whole sales, right? Now I want, for each region, I want to look at a trend. So what I'll do, the region, I'll drag it into a color. Wow, I got different trend lines altogether, one for each of the region. And let me again do the editing of the trend lines. Edit the trend line. I don't want a confidence band. Confidence band is one above and one below are typically created. Now let's say I am not interested in confidence band. So these are the 4 trend lines that are getting created for me for each of the products. Now let's say I am selecting only green. Okay, this is the kind of trend line that is coming out for green. So looking more and more flat, the south. But when I'm looking out for, okay, let me select now. Let's say I've selected central. So there is a kind of slight increase, right? And I could see that the sales is 6 times month of order date minus 237,154. So that is the number that is typically coming out, right? And p value, it is saying around 0.012. We'll talk about what they are. Similarly, when I'm going to the east, there is 10.47 times the month of the order date plus something. So there is a higher value of the slope here. The slope in the case of west, the slope in the case of west is around 10.47. Sorry, east. The slope in the case of east is around 10.47. The slope in case of the central is around 6.00. In case of south, more or less flat, the slope is around 2.37. And in case of west, looking a very high increase, again the slope is around 10.89. So I could see that for the central, west, east, south, the slopes are different. The slope is, what is the slope here in this equation? You could see it is saying 10.8915 times month of order date plus minus 434, whatever. Now what it simply means is, for every month increase, for every month, there is an approximate increase in sales of around 10.89. Whereas for the other period, this is for west. For south, it is looking like it increases just by around 2.37. For west, it increases by around 10.89 per every month. For south, it is 2.37. For east, it is coming out again to 10.47. And for central, the trend line is showing somewhere around 6.00. So for every month, on an average, the west and the east are going much faster compared to the central and the south. So I can very well get a good feel based on this trend line. Right, so I've taken 2 different coordinates, two different fields on x and y. So on one side I've taken the date related field, and on the other side I've defined the parameter. So I've taken the trend line, and I can very well do the differentiation, right? I got multiple trend lines in this example. Depending on what I am selecting, I can have multiple trend lines. So that can be the division based on any dimension. So the dimension that I'm using, they can be typically used as different kinds of factors to split one single trend line into multiple distinct trend line, right? So that is one aspect. Now within this also I can very well break the trend line. Now for each product I can find a different trend line. For each time period I can find a different trend line. So the trend lines can be created at different levels of detail. Now if I say I don't want the trend lines region wise, I want to see the trend line. So this is the overall. Overall I am expecting that my sales per every month will increase by around 29.74. On an average I am expecting my sales to increase by around 29.74 for every month. Now I really wanted to see how the situation is for every product or for every category. Which category is growing faster compared to the others? Now if I look at furniture, the slope is around 8.5. Office supplies, the slope is around 10.26. Whereas technology, the slope is around 10.97. So technology is growing at a much faster rate compared to the others. So that's one more thing that I can draw by looking at the trends associated with each product, each region, right? So I can really play around with the stuff. I got headings for each of the periods, and based on that I am able to identify the trend lines for each of the periods, and that is where I am able to do some kind of a deeper analysis, right? Now I would be more and more interested even in looking at, once I have the trend, I can do some more. I click on each of the trend line, right? I say edit. So if I want linear, I can go with linear. Otherwise I can try a logarithmic. Okay, now you see what is happening with the logarithmic trend lines, right? Let me put a trend line, show trend line, and in the edit I am putting a logarithmic trend line, or I can put an exponential trend line which is coming like this, or I can put a polynomial trend line of different kinds of degrees, degree 3, degree 4, degree 5. So I can put different kinds of trend lines of different kinds of shapes, exponential trend line. I can put all of them, and I'm showing the recalculated line for the highlighted point. So here it is showing this as the equation, here it is showing this as the equation, here it is showing this as the equation. So that's one part, right? I am able to go with different kinds of trend lines which are showing in general what is the kind of movement of that particular field over time, which is again distinct for each of the distinct dimensions which are acting as separators. Now coming to here, the different kinds of trend line. Let's say I am having a linear trend line. I assume the relationship, right, probably here for every month. So on an average, let's say every month, whatever is the increase in sales, every month the increase in sales is going to be constant. So the increase will happen at a constant rate. Then I can very well consider a linear trend line. So no matter how many months are increasing, I look at the sales going up at the same point in a straight line kind of a fashion. Whereas when I take a logarithmic trend line, I'm seeing that okay, it goes up But after a certain point in time, it may have to flatten out. It can't go up straight forever. So we are assuming some kind of law of diminishing returns here. After a certain point in time, I will expect that the sales will typically flatten off. So that is where I can choose a logarithmic trend line. And in some cases, I will be choosing an exponential trend line, which means every month on month the growth will be much more faster. So there will be a period of rapid growth. In that case, I'll choose an exponential trend line. And when we are choosing a polynomial trend line, I can choose anywhere between 2 and 8. So polynomial with 2 is nothing but quadratic, cubic. So like that I can very well choose, which means the relationship between the two variables here is complex, right? And I'll have some kind of an S shape. It does not go uniformly up or in one direction. It shows up and then down kind of stuff. And depending on this number, those many curves are going to happen. So when I'm saying quadratic, there will be two, one down, one up. Cubic, again there is one more down. Or so three different direction. If first one is down, second is up, then again a down. Again when I am looking at the fourth degree, again there should be some up. So that's a kind of a flexibility that different kinds of trend lines are typically being brought out to. So whichever one is fitting the data much appropriately, I can very well use that as a part of my analysis. Now, if I have to analyze those trend models, right? So I want to understand that. Okay, I have plotted them quite comfortably for each of the product, for each of the region. I have plotted them. So I have to really understand that model, and I really need to know whether the model that I have selected is creating any kind of meaning statistically. So by looking at Tableau, I really need to get some kind of a visibility into the trend model and the calculations. Okay, that we'll try to understand very simply using the linear trend to start with, and then we can very well go with the others. Okay, when we have done a linear trend, right, for each of the products we have a linear trend. So when I am moving it over this is the equation that I am getting. 10.978, let me do it for one of them, which is here I am doing for technology, right? For technology, the expression that I am getting is 10.978 times month, 10.978 times the month of the order date plus 435,518. So some such kind of equation is what it is getting, and it is giving me a p-value of 0.001 11166. Now, so this is what we are getting, and for every we are getting a different kind of an equation, right? For each one we are getting a different kind of equation. Here the p-value is 0.005, here the p-value is 0.000, and so on. Now, what is this p-value all about? The p-value is a very simple calculation. It's a statistical concept which says what is the probability that the relationship, the equation, right? What is the probability that the relationship that we have got, the equation that we have got, is insignificant? What is the probability that the equation that we have got is insignificant? is just random, has no significance. So all these cases it is saying that probability is just around 0.1%. So the 99.9% probability that this equation is significant. So the equation, just by looking at the p-value, when I say p-value is, in this case, what is the percentage? It's 0.1%, because it is 0.001. It's a 0.1%. It indicates that there is a 0.1% random chance describing the relationship between the values and the trend model. So it's only 0.1% chance that the trend model that I have got is insignificant. So which means the remaining 99.9% chance that the trend model that I have created is very well significant. Right? So if the p-value is less than 5%, we generally, as a very ballpark kind of a figure, I'll see if the p-value is less than 5%, then we say that the model, whatever we have got, the trend is significant. But if the p-value comes greater than 5%, then we are directly saying that the trend is insignificant and it cannot describe any kind of correlation with the model. So just by looking at the p-value, I can say whether our trend line is very much significant or insignificant. So this is insignificant. Now what I can really do is, along with simply looking at the data like this, along with simply looking at the p-value, I can also say, I can get into analysis, I can get describe the trend model, I can even go for getting some kind of details regarding this trend model. Now what we are simply putting is, so what all it is giving when I am looking at, so it is telling model formula, category times month of order date plus intercept, right? Number of model observations are 144 and the degrees of freedom is 6, residual degrees of freedom is 138. So it is giving me a details. So for that you may have to spend a separate session statistically to really understand what each of these numbers typically mean. But what we are primarily looking at is the wealth of the statistical information that is shown in this window. It is providing me a complete detailed description of the trend model. One, the formula. So this is my formula. What is the formula which I am getting? A linear trend model is computed for sum of sales given order date and month. It is significant at P less than 0.05. And if you come down here, the sales, so we are looking for technology. The equation is coming out as 10.978 is the slope and minus 435,518 is the intercept, and this is what is the p-value. Similarly for office supplies we have a different equation, and similarly for furniture we have a different equation. And overall you could see the R squared, yeah, this is one more measure. R squared is only 21%. Though the p-value is less than 0.001, the R squared is much lesser. R squared talks about the degree of explanation of the dependent variable with your predicted variables. So it's hardly 21%. So the 71% of randomness is present as a part of our value, which means there is a standard error of around 8,440. So which means whatever the value that we are going to predict, On an average, the error is to the extent of 8,440. It's not a very small value, right? So there is a good possibility that the error can be slightly on the higher side itself. So this is what the typical model is giving us, and I can very well get, so just by looking at it, and probably for each of them, if I really want an explanation of what each of these mean, I have to really refer to some kind of a statistics manual where I can get a good understanding. But as far as the visualization is concerned, this is one thing that we can look at. And the second, I can go into worksheet and I say show summary. So where a few interesting calculations are being done. So if you see for sales, okay, this is the sum, this is the average, this is the minimum, this is the maximum, this is the median, a few values. Now if I want standard deviation, I can get that first quartile, the third quartile, Q1, Q3, skewness, kurtosis. I can get all these things to get some kind of a framing in terms of how the values are typically lying, right? So this entire set of statistics, the summary I can get for each of the data that we have typically taken into consideration. And once we have computed this kind of trend, etc., Tableau gives me that kind of a facility where I can simply export the data, right, and including the data that is related to the trend model also. So once I am able to export it, now that also can be taken as an additional data. So I can do much more deeper analysis. I can visually analyze the trend model itself. So all that can be done. So which means I can very well go here. What can I do? I go to this, I say export, and I can very well talk about exporting this data. Now it does export to an Access data file, right? I can very well I can give it superstore. Let's say I'm exporting it to an Access data file called Access data file called superstore, right? So that is the name of the table data, right? So superstore.mdb, and within that the data table name is being shown as this. I can say connect after export, and I can say export the complete view. So it is generating, okay. Now if you look at the new data source, you see there are a new variables that are being created, right? You see that there are residuals that are created, you see predictions that are created. So these are some new set of fields that are created in the data, right? So the model that you have created, you can very well export. So the new data connection that we have got, it contains all the fields that were present in the original view, which were the order date, the category, all these were present. And now the new fields that are related to the trend model, which are predictions, the residuals, all these things are also present as a part of the new model. So which means I can do some new kind of visualizations now. I can very well say here I want to look at the residuals. I can do some plot. I can do a plot between the residuals and the predicted values. Okay. So the residuals and the predicted value I can do probably this time. I can look at it by each individual value, right? So I can say order date wise or something, or I can look at category wise. So category wise these are the numbers, or probably I can say I want to look at it order date wise. So instead of year I can very well take it as exact date. So this is how for each of the products, I am able to see the relationship between the predicted values and the residual. So the scatter plot is being chosen as a default one between the residuals and the predicted values, and it allows me to see how far each mark was away from the location that is typically given by the predicted line. So I can even look at whether all my residuals, whether all my residuals are very much distributed both evenly on either side of 0, or are they more towards the lower side, or are they lesser towards the lower side or higher side. So an uneven distribution would really indicate a problem with the trend model. So all these things can very well be created, and now a dashboard can very well be improvised by even considering these kind of variables also as a part, these kind of visualizations also as a part of my model. So that's how the trend models can very well be leveraged upon in Tableau. Now comes the next important aspect where I can look at the distribution in the data. Right? I'm not looking at only one value or something. I'm looking at the entire distribution. So I can look at confidence intervals, percentages, percentiles, etc. So even that, right, I can very well go to in this analysis. Probably let me do it on sheet 1. I'll go to this analytics tab here, and on this analytics tab I can very well the distribution analytics. I can look at the average line, the median, box plots, right? I can get the trend line. So I can drag and drop the desired visual analytic, any of these things. So let's say I want to drag any of this, let's say the distribution band. So I'll drag it, the distribution band. So I can talk about per pane, entire table, etc. So let's say I go with the per pane kind of stuff, and I can very well choose whichever is the one. So now I can talk about, okay, 60% of the average, 80% of the average. So that's the value I can talk of. Or probably I can say percentiles. So do I want 95 percentile, 80 percentile, or some such kind? Quantiles, the third quartile, second quartile. So what kind of quartiles is what I want? Standard deviation. So if I say -1 standard deviation to +1 standard deviation, okay, I'm getting a -1 standard deviation to +1 standard deviation, and I'm creating a kind of a band. So I can do it either for the entire table or per pane or whatever it is. I am doing the computation, and this is telling me that this is the -1 standard deviation to +1 standard deviation for the entire table. So these values are like above the 1 standard deviation, these values are below the standard deviation. So I can very well understand the kind of distribution of the entire data. Now the same way I can get the box plots, right? I can very well get the box plot. Let's say I'm dropping the box plot for this. Okay, now I can put the data with 1.5 times the interquartile range. So it is able to compute the box plot for me. Now I am able to get my box plot showing what is the 95 or what is the range. Now I could clearly see so I can reduce the view. So by looking at the view toolbar, I can very well decrease the size of the view to my liking. Now I could see that the 1.5, right now you could clearly see that the 1.5 interquartile range is lying between this and this. Majority of the plots are within that 1.5 times interquartile range. Probably this value is very much outside. So that is what I can very well treat as outliers. So this kind of analysis can very well be brought out through the understanding of the distributions in Tableau. So that's one more dimension. And then I can even get into the forecasting aspect as well. Along with the distributions, okay, let me take out all these things, right? So let me create a new sheet, right? This time let me call this sheet as distributions. The next sheet, I'll call it as forecast. What I'll simply do, just to understand, I'm pulling the sales, I'm taking the sales, let's say over different years. So I'll take the order date here and I'll take the quarter. So these are the sales, quarterly sales. Now all I am looking at is for each region I am taking it separate, and for all of them I am putting a trend line, but this trend line I don't want the confidence bands and all. I just want the trend line for each one. So I have taken a linear trend line. So up to here it is fine. But now I want to do the forecasting as well. For the next 1-2 quarters, I really want to do the forecasting. And that is where I can go with the analysis forecast. I'll say show forecast. Oh, I'm getting the numbers for the next few periods, right? So I'm saying show forecast and I've got some numbers for the next few periods. Now this is what I can do and edit, right? So again I go there, forecast. Now this is where I can talk about forecast option. So it is saying you can do an automatic for the next 5 quarters, and this is what are the forecasts for the next 5 quarters. It is done for 2015, right? Or I can do it like exactly for some number of years or until this many years. Now the source data is we have already got it in quarters, so I can go with it. And if there are any missing values, it is saying fill them with zeros. The forecast model use an automatic model. So otherwise, if the seasonality has to be ignored, then we are telling it ignore the seasonality in that. And okay, ignore the last 1 quarter. I don't want to even ignore it. So I want to consider even the whole. So this is one more, and I'm showing 95% prediction interval for each of them. So these are the things that go as a part of our forecast. We are giving a 95% confidence interval also to the prediction from our side. So we had all these values up to here, and going with our model, these are the predictions that are typically coming out for each one. We are getting now for each of the regions, there is a prediction that is coming out for each of the periods. Now that I can clearly get an understanding by looking at the forecast and the described forecast. Now this is what you could see, right? The time series, it is going with quarter of order date. So we are trying to measure the sum of sales. I am forecasting the 4 quarters for the next year. The forecast is based on Q1 2011 to Q4 2014. So I have not ignored any kind of values, and it's a quarterly cycle that I am looking at. Now what we are simply talking of is the for each of the region, right? For each of the region, okay, the Q1 In the west, it is going to be 53,000 plus or minus 13,000. And similarly for south, for east, for west, it is doing some kind of numbers plus or minus. And it is doing the seasonal adjustments wherever that is possible. And now it is also saying what is the contribution to the trend, what is the contribution to the seasonality. And at the same time, it is giving an assessment of the forecast for each one of them. So it's showing whatever it is doing a good forecast for the west as well as for the east. It was able to do an okay forecast for the central, but it's not able to identify a better forecast mechanism for the south. So that's the way it can very well give me the summary. And now some kind of measures with respect to the forecasts that are being performed. So it is talking about the root mean squared error, what is the mechanism that it has used for doing the trend, for identifying the seasonality, what is the root mean squared error, mean absolute error, right, mean absolute percentage error, Akaike information criteria. It is trying out different kinds of mechanisms to typically tell you or give you the kind of forecast for the next few periods. Now these are the estimates. Now if I look at the numbers, right, now if I convert this into numbers, I'll get my numbers clearly. Now I could get, let's say for 2015 Q1, right, in case of central, these are going to be the numbers for the next 4 quarters. For east, these are going to be the numbers. For south, these are going to be the numbers. So that's where in south it is not able to identify. So it came out with an estimate of a plane for the next 4 years. And probably for the west it has come out with this kind of numbers, right? So that's the way typically you can very well look at the system. It can very well give you the estimates, and it can help you in the forecasting process as well. Now to understand all these aspects, again we may have to get into the statistical significance aspects, and that is what will bring us more and more clarity. But when we are working out with Tableau as a data, to what extent I can use these kind of visualizations. Apart from the visualization, how can I add value to the visualization using all these kinds of statistical aspects is one of the major parts that I wanted to bring out in this session. So it's more like I can not just do the plotting. I can also look at the trend lines, analyze the trend that is present in my models. I can also look at the distribution that is present in the data apart from just the few values. And at the same time, I can also look at, if possible, doing the forecast using some kind of forecasting models for the next few periods, right? So all these are the various aspects that we can very well perform using Tableau. So thanks a lot for listening to this session. Thank you very much.